So to summarize all of this investigation here, let's look at page 3. And the general form of an exponential function is going to be y equals blue here. Before we always said y equals initial value times your multiplier to the x. Now we're going to shorten that and just say y equals a times b to the x power. Still the same thing. The x is still in the exponent, but now instead of saying initial value every time, we're going to just label that with an a. So a is your initial value. And then again, instead of writing multiplier, we're just going to write b. But again, b is your multiplier. The graph of an exponential function is always a curve. And it has a new vocab word here, a horizontal asymptote. So that is a new word for us. And if you look below here, we have our definition of a horizontal asymptote. So a horizontal asymptote is a horizontal line that tells you how a graph behaves as x gets larger or smaller. So to me, that's a very mathematical word definition and doesn't make a whole lot of sense. So I like this second part. It's an imaginary line that the graph gets really close to but never touches. So I like to call this the MC Hammer line. Why do we call it the MC Hammer line? Well,
can't touch this. You can't touch this. Can't touch this.
so you can never touch that asymptote. It gets really, really close to it, but never touches it. So it's the MC Hammer line in my mind. All right, so as we keep going here, an increasing exponential would look something like this. We're getting close to that asymptote, the MC Hammer line, but not touching it, and it curves upward. Remember the the equation or the multiplier that would cause it to increase is when your multiplier or your b is greater than 1. So you can put any number greater than 1 in here. So I'll just do y equals 2 to the x power here. All right, and then our decreasing exponential starts up high, curves down low, and gets closer and closer to our asymptote, but not touching it, because MC Hammer's there telling us you can't touch it. Our multiplier is when our number is between 0 and 1. And so any number between 0 and 1, we can write that. So I can say y equals 1/2 to the x power. Remember, all these exponentials do have the same domain and range. So our domain will be all real numbers, or negative infinity to infinity for both. And our range is the same for both. Again, our y value gets really close to 0 but never touches it. So it goes from 0 to infinity, not touching either one. So 0 is less than y, which is less than infinity. Again, because we're getting really, really close to this, but not touching it. It's the asymptote. All right, and then last but not least, how to identify the initial value multiplier based off different situations. So if we make this table here, we'll say 2, 4, 8, 16, 32. Our initial value, remember, is the y value when x equals 0. And to find our multiplier, we use that formula of a y value divided by a previous y value. So again, here I could take 8 divided by 4, so my multiplier is 2. If we're looking at a graph, remember our initial value is always when x equals 0, which also happens to be on the y-axis. So our initial value on a graph is the y-intercept. Where does it cross the y-axis? And then if you're trying to find a multiplier from a graph, I would say make it into a table and then do your formula. And then for a situation, initial value, words like starts with, originally, all of those synonyms mean kind of the initial value. When we go to multiplier, things like doubles, or triples. Doubles means times 2. Triples means times 3. But also, anytime we do these percent increase or decrease problems, that's also going to be a hint for the multiplier. So percent increase / decrease. So that's everything you should know about exponentials as of right now.